Oh, hi. Sorry, I'm just playing with benzene here. Uh, so have you ever wondered, hey, what does this whole chemistry of essential oils thing have to do with me? I mean, if it smells good, that should be good enough, right? And have you ever wondered, well, if I don't have this oil and a recipe calls for it, how do I know which oil I could switch it with? Well, all of that can be answered with chemistry. So on this week of Oil Camp, I'm going to be talking to you about the chemistry of essential oils. Okay, so one of the tools that you're going to get is the Essential Oil Chemistry Handbook that doTERRA has put together. So I'm going to pull that up and we're going to use that as our textbook today. And you're going to be able to look at the chemistry of these main constituents or these main particles of essential oils and be able to, using this handbook, figure out which essential oil you could replace one with if you didn't have one that might work similarly, or and understand why it's so important for the chemistry of essential oils to be how they're supposed to be. All right, let's get started. So this chemistry handbook, if you don't have it yet, let me know and I can get it to you. It's just an ebook, all right? And so it's going to look like this. So doTERRA works with, has a plethora of scientists that they work with to do not only research but testing in-house, but we work with a bunch of other labs, like third-party labs, to test our oils to make sure that it has the right balance of the different components, those different molecules that make up that essential oil. You're going to understand that better today. So we'll get through this first part. And I want to show you this first section here is really what's going to be helpful for you to pick an oil that is that would be helpful for you. So you have this wheel, all right? And they start with, you always start with a backbone. And we'll go over this. I'm just briefly showing you this at first, but you can see that you've got these essential oils grouped into restoring, uplifting, and energizing, okay? And so we have the backbone of a molecule, and then it has little things added to it, okay? And those are called functional groups. So the aldehyde, phenols, ketones, alcohols, and then just normal monoterpenes, those have to do with the functional group. And just like the name suggests, a functional group is going to help that molecule do a specific function. All right? So these ones, as you see, you can look at this and go, okay, which functional group is restoring? You look right there in the gray, aldehydes and phenols. Those are going to be restoring. And energizing, alcohols, ketones, phenylpropenes. And then for uplifting, you have monoterpenes. And you can see all the different essential oils that are in those different groups. So if you don't have one of those essential oils that, and it's called for in a recipe or something like that, you're wanting that restoring benefits, then you could look at one of the other ones on that section and see what it is. So we always start with like some sort of carbon backbone, all right? And then we're adding things onto it. That backbone are terpenes, and you have monoterpenes, sesquiterpenes, all right, and other things like that, but mainly monoterpenes and some sesquiterpenes and some other groups in there as well, but or backbones. But we're going to focus on monoterpenes and sesquiterpenes. Sorry. button. Okay, so that was the one that we just looked at. And then we've got, again, on the monoterpene backbone, we have more properties in here. So you have, here, let me zoom in a little bit more. So more on the monoterpene backbone. We'll explain that in a minute. But we've got esters, ethers, again, just simple monoterpenes, alcohols, okay? And these ones are restoring, clarifying, and calming. Now we move over here to our sesquiterpene backbones, and we're adding the functional groups of different sesquiterpenes that are mainly just sesquiterpenes. Then you have esters, ketones, and alcohols that will create soothing effects or stabilizing effects, all right? So just an explanation of the wheel itself. So you've got your backbone, the functional group, and the constituent name, and the actual essential oil that it contains. All right, so this wheel can actually kind of be put together as well, and you can like, you know, turn it around and such. It's pretty cool. Okay. So coming back to the basics of things, what essential oils are. Now, essential oils, they are plant derivatives. Hold on, I'm just going to try to get it a little more zoomed in here. So with essential oil chemistry, these molecules are what's called organic molecules. Now, this is different from organic like you would see at the grocery store. Different terminology. When we're talking in the grocery store and with like health food stuff, when you say organic, you have to have a specific certification for it, you know, no pesticides and da-da-da-da-da-da, right? Well, in chemistry, the word organic means that it's made up of carbon atoms, all right? It's mainly made up of carbon atoms. So even some of the different chemicals and things that are very harmful can be organic because, like in the chemistry term. So we're going to shift a little bit. When I say organic in this, we're putting on our lab goggles. We're a part of the chemistry lab, and we are we're talking about having carbon atoms in them. All right, and our bodies, our cells, we're all made up of these organic molecules, these carbon-based molecules. So then as essential oils, they are able to interact with our cells and our tissues really well, and in specific ways depending on how they are, all right, how their structure, okay? So different enzymes and things are also organic molecules that help us with all the different functions within the body, okay? So these essential oils can interact with them. Now that's what makes a lot of different other, in chemistry terms, organic molecules harmful to the body, because they might be these synthetic chemicals that that can interact with our cells and our organs and things in ways that we don't want them to. So the beauty of essential oils, since they're not synthetic, specifically doTERRA, is we guarantee that. We make sure, we go to painstaking efforts to make sure that it's that pure form made in nature. And so I like to think of essential oils in terms of that they are biological molecules. They're a part of natural biology, okay? Not synthetically made in a lab. So when it's organic molecules that are made in a lab, our body doesn't know how to deal with it. If it's organic molecules that are biologically made in our bodies, in plants and things like that. We've all grown up together, and so our body knows how to interact with them and can do wonderful things, and we're proving that more and more. Okay, so that is what we're looking at here. I'm going to try to get over here. And so with essential oils, they're not actually oils, they're not lipids. It's a completely different molecule. So it's not a part of the lipid family. If you remember from like your biochemistry times in high school and junior high, covering those different main macromolecules, one of those main macromolecules was a lipid. There's a long string of carbons and phosphorus. Like, it's not that. It's not that. There's much smaller molecules, and it has different functionality and different structures. Okay, so but they are soluble. They dissolve in fats. Okay, so that went back in the day when the scientists were naming molecules, when they came across these essential oils and they dissolved in fats, they called them oils. When they dissolved in oils, they called them oils. Okay, so so they're essential oils. They're the essence of plants. Okay, and plants produce them for a lot of different reasons and a lot of different places on the plant. And it depends on which place on the plant you are working with, which place on the plant you are getting these oils from will change the chemistry of it. I mean, it's the same with like, if you were to take cells and molecules from your hair, that's going to be different from taking them from your muscles. It's similar to that, in that you have different molecules made different areas. So doTERRA pays attention to that. Some companies do not. So doTERRA pays attention to that because that has a big effect on their how they can help the body. Okay, so there's a lot of different ways of extracting them. The main way is cold press, steam distillation, and then solvent extraction. Sometimes when you have really, really light molecules, like with flowers and things, you have to use a solvent, something to dissolve those molecules in, and then you extract them out of that thing you dissolved it in order to get them out, because they're too delicate, they're too tiny. And so for a lot of the flowers, you're going to be using a solvent. For citruses, you're going to be using a cold press, and for a lot of your other ones, it's going to be a steam distillation. Now, it's when you are looking at a essential oil, it is not just one compound. So it's not like, oh, I've got a peppermint molecule and a lavender molecule, and okay, no. With peppermint and lavender and all these essential oils, there's a bunch of different molecules that go into making an essential oil, and it's like a orchestra, all right, and you need all of them. Now, in a one drop of, sorry, I'm still learning how to move this thing around. In one drop of essential oils, it contains, let's see, 40, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 40 million trillion, okay? 40 million trillion of these molecules, okay? So they're volatile aromatic compounds. That means that they go off into the air, all right? They go off into the air, and they can be used by our body as well. Now, 40 million trillion, that means that with one drop, there's enough molecules to be distributed between every single cell in your body. Super powerful. So when you're taking these internally, especially, you have to know what these essential oils are made of. You have to be able to act with confidence, and we can with doTERRA. So they can interact with our cells, and there's a specific like ratio that we want to look for, and that we work with awesome labs that knows that right ratio. Okay, so let's talk about some of those different, the backbones and the functional groups. That backbone, remember I was talking about the terpenes. We had monoterpenes and sesquiterpenes. So with monoterpenes, you have 10 carbons as a part of its backbone, all right? So, let's see. So, when you see on these little structures here, these each are a molecule, and at every point where they come together, like every corner, that you assume that there's a carbon there, all right? And the lines between them are bonds. And so you see that sometimes there's 2 lines and sometimes there's just 1 line between the different corners. That represents like a single bond or a double bond. So obviously if it's 2 lines, it's a double, 1 line, it's a single bond, all right? So on here, and so I'll stop sharing for just a second. Right here, this is benzene, all right? And it can be, we're gonna look at this in a little bit, but when you have sharing between 2 electrons, so hydrogen is sharing an electron with carbon, and carbon is sharing with hydrogen here. So we've got hydrogen and carbon. So this is a single bond, the sharing of 2 electrons between 2 atoms. This is a covalent bond. When you have here, this carbon and this carbon share, so that's 1 bond, and share, that's a second bond, all right? So then you have a double bond here. And so that's more of what it actually looks like. 1 line represents the sharing of 2 electrons. It's really quite ninja. So we've got a pattern here of a single bond, double bond, single bond, double bond, single bond, double bond, okay? So if I added like a different group on here, we're gonna see what that will turn into. So we can have also larger backbones. So those ones have 10 carbons. These ones here in our sesquiterpenes, they have more, all right? And with the sesquiterpenes, we can count them here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, we've got like 15 in here. 15 there, okay? So we have, they're bigger molecules, okay? And so it's harder for sometimes our body to process them at different times, but because they're biological organic compounds, our body is wise and knows how to use them. So when we are working with these essential oils, these bigger molecules are able to do things like interact with our enzymes. You know, our enzymes in our body is what causes things to happen in our body. So really powerful when we're talking about sesquiterpenes. It really affects the function in general of a cell, that enzymatic function. So very powerful. All right, functional groups. So you have those backbones of either a monoterpene or a sesquiterpene, and then you have stuff added to it. And so in red, you're gonna see, so this is a monoterpene with an alcohol functional group. And now, oh my goodness, alcohol. Alcohol just means it has an OH on it. So you have oxygen and a hydrogen. So I'll put that on here. So I've got my oxygen atom. So I'll add this. I'll add this alcohol onto here. So oxygen has, I'm just going to briefly do this, has 6 valence electrons. If you remember your periodic table days, then you could see where that is and why that is. And so he wants to have 2 bonds. So he's going to bond with a carbon, and he's going to bond with, so he wants 8 Remember that octet rule, 8. So now here is our oxygen, our alcohol functional group. So with our alcohol functional group, it has specific functions. So with the alcohols, that OH backbone, or that the backbone, and then it has an OH on there, the oxygen bonded to an hydrogen, that's the alcohol. So when we're looking at that, you can see right in here, some of them that in general, alcohol molecules have names ending with "all." So terpenol, citronol, geraniol, linalool, okay? So all those "all" ones, OL, has that functional group on there. And with the properties of alcohol, so if you have an alcohol functional group on there, it is relaxing. It can be a relaxing aroma, helps soothe anxious feelings. Topically, it has repellent activity, cleansing properties, helps the skin look young and healthy. Internally, so if we're taking it internally, it supports the circulatory system and calms the nervous system. So oils that in monoterpene, high in monoterpene, you've got melaleuca, okay? And you can smell these. Let's see, I left my geranium in there. Melaleuca, geranium, coriander, basil, lavender. Basil, coriander, and lavender. Okay, so I'm gonna smell these, and I would invite you, so lavender, melaleuca, geranium, coriander, basil, lavender, and see if you can kind of smell some similarities. Okay. Okay, so smelling those different, I just spelled melaleuca, lavender, coriander, and basil for our alcohol functional group. And so those calming, relaxing things. So if you're wanting that calming, relaxing stuff, you now know that you can go to these different essential oils, melaleuca, geranium, coriander, basil, lavender. They can have those different effects aromatically, topically, and internally. Okay, aldehydes. So an aldehyde molecule with an aldehyde group. So an aldehyde group characterized by a carbon double bonded to an oxygen. All right. So you can see the two lines in there between. Just stop share for a second. So this oxygen, get rid of the hydrogen. So this carbon is going to want to, you gotta break off that second bond with that other carbon over there. So we've got one bond to the oxygen already, and we're doing a second bond. So we've got double bonded on there. All right, so this is our double bonded. We've got our aldehyde. So let's learn about aldehydes. So with an aldehyde, let's see, start moving it over. So you have the backbone and then you have that double bonded oxygen. And you have, these typically end in al, like, or aldehyde, okay? Geranial, neural, cinnamaldehyde, cumanal. So not all, but al. So an example of an aldehyde group in the compound terpene 7-ol, a monoterpene, okay, aldehyde found in cumin essential oil. So properties of an aldehyde They're calming, relaxing, protecting, okay? Topically, they may reduce the appearance of blemishes, keep skin looking healthy, support oral health, hygiene, provide warming sensation to the skin. Internal, support the health of the cardiovascular, digestive, immune, and nervous system. Wow. Many essential oils high in aldehydes are also known to support healthy metabolism. So some of these things that you might think, okay, warming to some might come to mind. So did you guess any of them? Cassia, cinnamon, melissa, lemongrass, lime. All right. So that right there, with that double bonded oxygen on there, that's the different things that these molecules can do when you've got that double bonded oxygen. Amazing, right? That little change can do that. Okay, so alkenes, that is where you have just a double bonded, some different double bonded carbons. Okay, so we've seen the double bonded carbons already, so I won't show you that. So you have the monoterpenes. Alkenes are known for their antioxidant properties, large number of double bonds, and existence of a ring structure makes them excellent accepting the lone electrons containing free radicals. Okay, so they that's how, when they accept those free radicals, then that's how that they are antioxidants, because they're not damaging the rest of the body. So aromatically, so when we're breathing it in, has a very pleasant fragrance. Topically, it has antioxidant benefits for the skin and tissues. Internally, also antioxidant benefits for the different organs. It may support the nervous system, immune, digestive, reproductive, integumentary, and circulatory system. So frankincense, Douglas fir, some high in monoterpene alkenes. Frankincense, Douglas fir, blue tansy, lemon, wild orange. All right. Oils high in sesquiterpenes, so these are bigger alkenes. Ylang ylang has it, black pepper, copaiba, melissa, and ginger. So you can start to smell these different things and start to identify these different molecules as you smell them. Okay, so esters. With esters, so this is a little different molecule here. So we've got the double bond, and then we've got the double bond to the carbon, and it's going to another one. That carbon is going to an oxygen, and that oxygen is going to another carbon. So it's surrounded by that. Okay, so and we've got like an additional shorter chain. Okay, let me show you this here. So we had the carbon. Oh, I need to get more hydrogen on this carbon, make him happy. Okay, so we've got the carbon and double bonded to the oxygen there, then single bonded to the oxygen, and that oxygen is bonded to another carbon, and then he's full with the hydrogens and such. Okay, so I don't have a great backbone on here, I don't have enough carbons, but this group right here is the ester. All right, so aldehyde, let's see, aldehyde, we had just the double bonded oxygen, and we've got the ester there. All right. Let me just double check, make sure I didn't lead you astray. Yes. Okay. So with these ester groups, you have so you have the 2 oxygens, that's the key in there. Properties: relaxing, soothing, balancing aromatically, rejuvenates the skin, soothes tissue, protects against certain environmental threats. Internally, it varies with the different essential oils, but some esters can support healthy cardiovascular, immune system, digestive system, and other esters are not necessarily recommended for internal consumption. So, some of the other ones with esters, now lavender was also one that had alcohol in it, right? Well, it also has a good portion of esters. Now, Roman chamomile, helichrysum, or vitae wintergreen. Okay, so you can kind of get an idea of these different functional groups that are on here. And there is just so much great information. So we've got esters in here that are soothing to the emotions and promote clear airways. So cardamom, eucalyptus, when I talked about airways, you probably thought of that. That's thanks to esters. So not or ethers. So esters over here, ethers is just that double bonded oxygen, just that double bonded oxygen. Or the single bonded oxygen to 2 different carbons, single bonded in 2 different areas. So it's like in the middle. So ketones, it's very similar to aldehydes, right? But it's like smack in the middle. It's not on the end. It's not on the end. So those ketones, when they have the ketones in there, you've got energizing, uplifting, spikenard, frankincense, spearmint. All right. The phenols, that's where you had that ring. It's the ring with the alcohol group on it. That's a phenol. And so we had made that. We had made that. And phenols, invigorating, cleansing properties, antioxidant properties, great stuff. Okay, and then phenylpropenes. So phenylpropenes, you have phenol, but then you add another chain onto there. The prop means 3, so add those 3 carbons onto there. And they're energizing, skin care, skin health. So fennel, myrtle, anise, star anise, and basil. Okay, so you can see these tiny molecules. And remember, there's 40 million trillion of these different types of molecules in each essential oil. And the balance of the different things in there makes them what they are. And if you, even with the little parts, so you can now, in this next section, it goes into the makeup, the percentage of what it would be. So you've got the key down here. Got the key down here of the different functional groups and whether it's monoterpene, sesquiterpene, all right? So like just looking at bergamot here, that's right there, we see the different percentages, and these are the ideal ranges for the proper therapeutic benefit for bergamot. And then the functional groups, you see the majority of it is green, so alkenes with that, and then the red is esters, and the blue is alcohols, and then the little sliver is the aldehydes. All right, now we're finding that those little slivers make a big difference with the how essential oils function. So even with black pepper here, so you've got a majority So we've got that the majority of it is alkenes, and then you've got these really small percentages with other things, but those really small percentages are still really important. Okay, so you can see with this that you can see what all these different essential oils are made up of, and all their different, and so you can go into and kind of compare if you wanted to learn more about the chemistry makeup and the functional groups of these different essential oils. Okay, so if we go back to the beginning, actually I think I can do this. If we go back to the beginning, then this is where, and I hope you can see the importance of having the proper chemistry with these essential oils, because these little groups, these little molecules have such an effect that if they're not the biological organic, like made from the plants, it can have some very negative effects, right? So having these, and again, so coming back to here, monoterpenes, we've got our aldehydes, phenols, that's going to be restoring. And so we can look at those different things and those different, the different essential oils that can be for restoring. So if you're wanting to make, like, maybe you work on some of your own blending and things like that, make sure you're working with a book or something that gives you some guidelines regarding that. doTERRA, when you mix different essential oils, the different constituents can interact together and such. And so it might not have, it's not a 1 + 1 = 2 type of thing. You have, it might divide something, it might multiply something. Okay, so the scientists at doTERRA, when they're making a blend, they know how these different molecules interact, and they have very, very specific ratios of the different essential oils. But there's lots of recipes out there. I don't want you to be afraid or anything like that. I just want to have your expectations clear. Okay, so make sure you're using those different guidelines, but you can see, okay, if I don't have a specific essential oil that I want to be energizing, I can go to something else on that list. If I want uplifting, I can go to something else on that list, right? If I want to have a specific functional group, okay, if I want to look at a specific functional group, then I know which one would be ideal for me. And looking at these ones as well. You can look at, again, if we're having monoterpenes, these ones are so small they can get inside the cells really easily and such. So if we're wanting to interact inside the cells, looking to monoterpenes. And if we're wanting to look at really being powerfully affecting the function of different cells, we can look to our sesquiterpenes, our big backbones, All right, get a backbone. And we can do that. Okay. So one thing that's really exciting, that I want to share with you is doTERRA has just been accepted as a member of, and I just found this out last night actually, so I'm going to pull it up because I don't want to say the name wrong. So there is this organization, this like research organization that that figures out the proper usage of different fragrance molecules and things. And And so they're like the authority. So when we're talking L'Oreal, all those different like main companies having to do with fragrance, having to do with molecules that we're going to be putting on our skin and in us and such. There's an organization. It's a global organization, and they have to do a bunch of research and stuff. It's called the Research Institute for Fragrance Materials. All right, Research Institute for Fragrance Materials. And this team of scientists, like, they are who says what is safe, what is not safe, how much, and the research that proves it. All right, that peer-reviewed research that proves it. Well, doTERRA is the very first essential oil company, and it's the only essential oil company that has been accepted as a member of this research institute. All right, so the doTERRA scientists, with their body of knowledge and their research and everything, is joining forces with them. And so we'll have access to their plethora of knowledge, and they're really excited. I'll put this on in the unit so that you can read the press release for it and such. They're really excited to work with doTERRA because of our body of knowledge that we have made regarding essential oils. And the exciting part is a lot of the research out there is based on one molecule. All right, one molecule, and I think it's called RIFM. So RIFM knows, and doTERRA knows, we know that essential oils, their efficacy, their safety and all of that does not depend on one molecule. It's all those different molecules working together. So working with them, we're going to really be able to get so much more peer-reviewed research out there to show and to prove you have to have pure essential oils. You have to have the full symphony of these essential oils with all the different molecules to get the therapeutic benefit that you're looking for. Okay, and this is such a huge reputable company, and it's a research institute. Okay, and it is exactly what doTERRA is about. And they, doTERRA had to apply and all this, and they had to get approved. And because of, they said in the press release, because of doTERRA's standards regarding sourcing, regarding testing, and all of that, they have accepted doTERRA in to this research institute. Okay, so super exciting especially for geeks like me, just to know that we are going places in this industry that no one else is going, where nobody else is going. All right, and we're setting a foundation for and setting the standard for essential oil companies, and going places that really nobody can necessarily follow, because they haven't laid the structure with the co-impact sourcing and all of that. And it's going to be really, really exciting as we move forward to be able to reach more people and have better quality essential oils, and really be able to utilize these wonderful tools, these wonderful essential oils in more effective ways, and in broader arenas. All right, so doTERRA is just expanding. This is just the beginning, and so I'm really excited to be a part of this, and I hope this helped you today. Hope you had fun putting on your lab goggles and looking at some different molecules, figuring out what different things are. We've got our ester here, right? Got our ester group on there. And seeing how powerful chemistry can be. And I hope you have fun figuring out how you might be able to replace some different essential oils with other ones if you need to. So I will get that book uploaded. It is It's one of the ebooks that doTERRA has created, and I'll get it on there. All right. So you guys have a great day, and I will talk to you later.